Okay, back to work. Like a fool after my little Play-Doh demonstration, I hit stop recording instead of pause, and I don't have any editing software to even just to knit two videos back together. So we'll have to do two separate videos, and I don't care if you don't care. But for 31, I just explained what I think was pretty important here, which is to realize that for this problem, we are squashing a right circular cylinder. That means we will have a dH dt that is negative. Now, did they tell us what it is? At the moment when the radius is 3 and its height is 4, the height is decreasing at a rate of 0.2. So we got that. Oh, this was the problem with the typos, of course. So when I said what is the rate of change of the height, obviously I gave you the rate of change of the height, so I meant what's the rate of change of the radius. And also over here, we said the height is decreasing at a rate of 0.2 cubic yards. Of course, it can't be cubic yards. It has to be plain old yards. So scribble that out. But if dH dt is negative 0.2, then dr dt is going to be some positive value, but we don't know it. But we did say dv dt in this problem. That's actually going to be 0 because it says right here the volume remains constant. Okay, okay, great, cool. What's the height at the moment we're investigating? The height is 4 and the radius is 3. And again, we could use the height and radius to figure out the volume, but that's going to end up coming out of our equation when we differentiate anyway. So I'm getting a little sick of writing this, but if volume is pi r squared times height, then by the time we differentiate, we'll end up with a dv dt. That equals 2 pi r dr dt times normal h plus pi r squared times dH dt. So we take everything we know and we substitute it in. The rate of change of our volume needs to be 0, because again, if we're squashing a big hunk of Play-Doh, we're not losing Play-Doh or gaining Play-Doh. Our volume stays the same. But as we squash, we're squashing until the radius is 3. And the rate of change of the radius is what we want to solve for. So dr dt is the variable we're after. Then we are squashing until our height is 4. And pi is pi. The radius is still 3 squared. And dH dt is the rate of change we know. We know that it's negative 0.2. Alright, so from here we can get to work, bearing in mind that dr dt, that's the guy we're solving for. So as we do this math, I don't know. I guess it pretty much makes sense. Let's take this negative guy and just kick him to the other side since we equal 0. So this is what? 3 squared is 9, times 2 is 18, but it's 0.2, so it's 1.8. So 1.8 pi. And that'll be chilling over here on the left-hand side. Over here on the right-hand side, again, this looks like a 9, but don't get fooled. That was a 4. So what is this? 6 times 4 is 24. So this is 24 pi times dr dt. Which means to solve, we just divide by 24 pi. And everything cancels over there on the right, leaving us with dr dt. And if you want to give me an answer that I don't hate, then you might consider multiplying the top and bottom here by 10, because that'll turn 1.8 into an 18, give you a nice whole number instead of a decimal. It'll turn the 24 into 240. And then, of course, these pi's will cancel. But you now have a nice answer that is a fraction instead of a decimal mixed into a fraction, because those are kind of forbidden. I'm not accepting those. So we've got an 18 over 240, which I can chop in half to get 9 over 120. Now I can't chop them in half anymore, but they're both pretty obviously divisible by 3. So I now have 3 over 40. And it looks like that's the best we can do in terms of simplification. So it's 3 over 40, 3 over 40 being approximately 0.075. 0.075 actually happens to be exact as well, which does mean that I guess you could get away with giving me just the 0.075. But I just want to remind you real fast. You cats know your calculator can do this stuff for you, right? So here's your calculator. Remember, if you've gone through all the trouble of typing this stuff in, you could have just done the 1.8 divided by 24 in the first place. And just remember, you can go into your math menu at any time and choose convert to fraction, and it's going to do that math for you. So if you want to stay on my good side, then give me the fraction, 3 over 40. It's not like it's hard to do. You don't have to do what I did. You don't have to understand this multiplying by 10 to get back to whole numbers and then reducing. You can use your calculator and you can give me the 0.075 and you can give me the 3/40ths, and you know that's going to keep me happy. And you guys are supposed to want that. You guys are supposed to want me to be happy, not angry all the time. So what is this? It's the rate of change of the radius. So what are the units? It would be plain old yards per second. So there you go. There's another problem down. This one I thought was somewhat interesting, so make sure you get it. And I forgot about my face, so forgive me. I'll move my face. And now you can see the answer. So again, the answer was 3 over 40, aka 0.075, and it's yards per second. Okay, let's do another. So 32. 32 had some vocabulary in it that I thought you guys might not understand, so I'll explain that if I have to. Not like you need to understand the vocabulary. I want that to go away. So goodbye, calculator. All right, so this says a mechanic is reboring. Bore, to bore. That means to drill, right? So he's reboring. He's drilling into a cylinder. So mechanic, they work on cars, right? And cars have engines in them. This will be the world's worst drawing of an engine, but an engine, it's like a big block. And they literally have little cylinders drilled out of them, right? And then there's a thing called a piston. And the piston is like a little disc with a rod on it. And that thing pushes down into the cylinder. Maybe, I don't know if you guys know this, I don't know if you care, but that compresses the gas and then you ignite it and blah, 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 who cares? Anyway, suffice it to say, there's this big old block, and that block had a cylinder drilled out of it so that a piston could fit down into it. But maybe this guy's restoring an old car, like a 57 Chevy or whatever, but he needs to fit a new piston in there. So the inside gets all corroded and stuff, so they literally do drill down in, and they kind of widen it out a little bit. They get back to nice fresh metal, they use a slightly bigger piston, and the thing fits in there. So blah, 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 that's what's happening. What does that mean to us? Well, I'm pretty sure it means that the height of the cylinder, the height is for sure not going to change. It's the height is just however tall this block of the engine block is, right? So as I drill down, I'm expanding the radius to get a bigger cylinder, but the thing doesn't get any taller. It's got a hole at the top and a hole at the bottom. So whatever its height is, that remains the same. Sounds like that means for us, dH dt this time is 0. Okay, there's engine repair with mechanic Fantagrossi. I'm going to clear all this. Hopefully you understood what I just said. So it says a mechanic is reboring a 6-inch deep cylinder. So it sounds like they just told me that the height is 6. And because of all the stuff I said, I know that dH dt, that height isn't changing because of the way this problem is working. So that's 0. It says the machine they're using increases the cylinder's radius by 1/3000th of an inch every minute. So sounds like they're giving me the rate of change of the radius, dr dt. And it's crazy slow. It is 1/3000th 3,000th of an inch per minute. But that makes sense too. I mean, you're trying to drill away metal. You got to do that slowly, or else there'll be a ton of friction and it causes problems, and I don't care. All right, so how rapidly is the cylinder's volume increasing? They're asking you to solve for dV dt. They're wondering, what is this thing? When the bore diameter is 3.8 inches. All right, so this said radius, this says diameter. Be careful because that is obviously a mismatch in our dimensions here. So I don't care about diameter. Make sure you change the diameter from 3.8 to 1.9. We only care about the radius. But here's our big set of given information. We're going to go back to our same old formula, which of course is that volume equals pi r squared times height, which of course means that the rate of change of our volume is equal to 2 pi r dr dt. How many times have we seen this today? A lot. Times the height plus pi r squared times dh dt. All right, so maybe I'll just say right away, because of the nature of this particular problem, because dh dt is 0, that again tells me this whole second term can essentially just drop away, and I only care about the rest of this stuff now. So dv dt is again what we're actually trying to solve for, so nothing gets substituted in there. That's going to be our variable. Then we've got a 2, we've got a pi. We were given not the radius, we were given the diameter, but we can easily turn that into a radius. So in goes our 1.9. Then dr dt we were given, it was that very slow 1/3000th, which was given. And then we've got the height. We know that the height of the cylinder is the 6 inches. So this is a 3,000th of an inch, 6 is an inch. Yeah, so all the other inch things, all those units line up. So from here we just do this math. And I don't know what this is, so I'll use my calculator. So again, if I were you, I would just do all the stuff that's in the numerator. So that's all numerator, that's numerator, that's numerator. So we know that whatever dV dt is, it's going to be something that's over 3,000. And then in the numerator, just leave the pi out. Do everything but the pi. So it'll be 2 times 1.9 times 6. So that's 22.8 pi. And again, I'm desperately begging you not to leave decimals. So if you want to just kick this decimal over one place, then you're just multiplying by 10. So multiply the bottom by 10, and you land on a 228 pi over 30,000. Or again, you've got your calculator. Let your calculator do the work. What did we just have? We had 22.8. As long as you leave the pi out of your calculation, your calculator will do this for you. Divided by 3,000. Press enter. Now you get a decimal, and this decimal terminates, so it is fine to just give me that. But again, I would much prefer that you convert to a fraction, and you'll give me the 19 pi over, well, I can't see it anymore, 19 pi over 2,500. So this is the best possible exact answer. And then if we convert this to a decimal using pi, then, well, I don't know what we get. We get that thing times pi. So we get 0.0239. And this is a rate of change of volume. And since we were measuring inches every minute, this must be cubic inches every minute. So there's your answers for 32. And then I think, mercifully, there's only one more. Oh, there's no more? Great. Very happy to be done. All right. Hopefully you guys understood this. If you did not, then just hit me up with questions. Although I guess you won't watch this till Thursday. And by Thursday, it'll be too late. So understand this, or else you're in trouble. All right, I'll talk to you later. Bye.